Hi everyone, I hope you are fine out there. Today we are going to introduce the lesson about three-dimensional shape. Let's start. Main functions of three-dimensional shapes in life context are to contain contents for our daily use, for example, container for a sugar, for storage, example being the water reservoirs, for shelter such as housing and places of worship. For packaging, example being of the card box used for shipments and other purposes not mentioned here. The following are the three-dimensional shapes that we are going to learn about. Cone and triangular prism are for level 4 only. We have the cube, which have 6 faces, just like the cuboid, which we normally call the rectangular prism. It's got 6 faces. The sphere is got 1 face. The cylinder has got 3 faces. The cone has got 2 faces. And the triangular prism has got 5 faces. Example of rectangular prism and its real life context for all levels. The surface area there is 2 times length times breadth, that is this part and that part, the length and the breadth. So you have these 2 parts. 2 times the length times the height, that is this part and this part. We have the length and the height. 2 times the breadth times the height. This is the breadth and this is the height, and therefore the faces are this face and that face. And when you fold them together, they will give rise to this box. Example of cubic shape and its real life context for all levels again here. Cube in numbers to illustrate its length, breadth and height. In this case, the breadth, length and height are the same. Hence we call them S for sides, because all the sides are the same. If you look at the length, it's got 1, 2, 3 blocks, and the breadth 1, 2, 3 blocks, and the height 1, 2, 3 blocks as well. Hence we have what? 3 multiplied by 3 multiplied by 3, which is 3 cube, which is our volume. So our volume is S cube. And our surface area is all the 6 faces. All the 6 faces, which is 1, the opposite of it 2, 3 here, the opposite of it 4, the top one 5, and the bottom one 6. All the 6 faces are the same, and therefore their area is 4S. If you remember in our 2-dimensional presentation, what did we say? The area of a square is 4S. Hence we have the surface area of a cube as 6 multiplied by 4S. An example of this in real life situation is the dice. Example of cylinder and its real life context for all levels again. Cylinder with surface area and volume indicated below. The surface area of a cylinder is the area of the top, which is a circle. The area of the top, this one, is pi r squared. The area of the bottom, again, is a circle. So it's going to be what? Pi r squared. The area of the side, which is 2 pi r. The area of the side referring to the curved side. This curved side is 2 pi r, meaning is the circumference of the circle multiplied by the height. And its volume is pi r squared times height. Pi r squared, remember, is the area of a circle. And height, that means the volume is an area multiplied by height. This candle is an example of a cylinder. Image of a sphere with volume and area. A sphere is indicated just like this. Remember, a soccer ball, the one that has been used in 2010 World Cup. That is an example of a sphere. The volume of it is 4 divided by 3 multiplied by pi multiplied by r to the exponent 3. That is 4 over 3 pi r cubed. The surface area is 4 pi r squared. The diameter of a sphere, of a circle, just like we have mentioned when we were presenting the two-dimensional lesson. We said the diameter is 2r, and the radius is diameter divided by 2. Example of a cone and its life context. This is applicable only for level 4 students. The vuvuzela. If you look at the vuvuzela, the top part resembles the shape of a cone. In a cone, we have this line, which is what? The slide height. This line and this line, or this side and this side, as the slant height. And this one, this part or this line is the perpendicular height because it's perpendicular to the radius. So we say it's the perpendicular height. If you can look at this shape, we have what? A right-angled triangle. In that right-angled triangle, that slant height becomes our hypotenuse, the step ladder. And the R becomes our horizontal, and the H, the height there, becomes our vertical. And this angle is 90 degrees. Hence we have the slant height can be the square root of R squared plus H squared, the theorem of Pythagoras, which says the square of the hypotenuse is equal to the sum of the square of the other two adjacent sides. And the volume thereof is 1/3. 1/3. Remember, this formula is for what? The volume of a cylinder. So the volume of a cone is 1/3 the volume of a cylinder. So it's 1/3 pi r squared multiplied by height. Curved surface area, the CSA, is pi multiplied by radius multiplied by the slant height. Example of triangular prism and live contest for only level 4 students. You remember the swing in the park. That is a good example of what we call a triangular prism, where we have this part as the base, the two parts are the triangle, and this space and the other space there becomes your rectangle. This part as a rectangle, these two triangle, and this part and the other part as rectangle. These are our rectangle. Our triangle. This part and that part, and this part is our rectangle. That our rectangle, and the base is our rectangle as well. So that we have what? The volume is half base times height times what? The length. Half base times height times the length. So it becomes the area of the triangle multiplied by the length. And its surface area is 2 of the triangles. Remember this formula is for triangle, half base times height. Which triangle? This triangle and that triangle. Or this triangle and that triangle. 2 of this triangle plus 2 times breadth times length. 2 of the rectangles. Which are those rectangles? The rectangle that we are talking about is this one and this one. And the last one is length times breadth. Length times breadth, it becomes this rectangle. Thank you.